Hi, this is Mike Pilecki from the National Centers for Environmental Information in Asheville, North Carolina, and going to talk to you about the U.S. Climate Reference Network operational changes in new soil moisture products. The USCRN, of course, as you all know, has a set of soil moisture probes at about 114 of our stations across the United States. We conduct manual quality control of the soil moisture data here at NCEI, and we continue to improve our methodologies for automated quality control, as Ronnie Leeper outlined briefly earlier today. And we'll continue working on that during FY22. One of the biggest changes that's going on is almost completed. We have installed a new soil probe from Aclima at 46 of our stations across the United States, but they've been not being used for the layer average for soil moisture until now. At this point, we have gone ahead and finally finished quality control and analysis of the impacts that would have on our data, and we're confident that we can now incorporate the soil moisture data into the layer averages, and the recalculation process is about to begin shortly. It'll take place over about 2 weeks, and at the end of that process, the layer averages will be different for many of these stations from when Aclima was installed onward, and so we'll send out a notice to folks so that they will download the data again at these stations. Also, with regards to operations and maintenance issues, we are in the process of taking several of our research projects and taking them to operations, where we will be updating standardized soil moisture on a regular basis now, instead of having a static beta product out there. And also we'll be including a new product that's related to drought indices that's based on the standardized data set. So as I said, there are 46 stations currently that have Aclima probes installed, and there will be more in the near future, as we have now, well, it's not really post-pandemic, but we have gotten permission now for our colleagues at the Atmospheric Turbulence and Diffusion Division in Oak Ridge to start doing annual maintenance visits once again, after interruption approaching 18 months in length because of the COVID crisis. So where there are failed probes, they will be replaced with Aclima probes. We'll have a network that's a mixture of Hydra and Aclima probes for the foreseeable future. And so the analysis we did is important to show that we can go ahead and move forward with the data in its current form. Overall, we found that the Hydra and Aclima soil moisture observation differences are very small. There are a few exceptions, a few cases where we have heavy clay soil, where the Aclima is definitely an improvement over the Hydra in terms of its quality of its measurements, and therefore has a more significant difference in those particular locations, of which there are a handful. It's not by any means a large portion of the network. One of the things that we can look at is to see how the seasonal cycle of the differences change between the time when we add the Aclima to the layer average, or just look at the pure Hydra layer average. And you can see that these numbers are very small, within plus or minus 0.01 of volumetric water content, And you can see that there is a seasonal tendency, though, that during the wetter season in the spring, the climas are slightly drier, and in the fall, when it's usually the soil is drier, the climas are slightly wetter than the hydras. Unfortunately, the temperature differences are much more substantial, which can reach 0.5 or 0.6 degrees Celsius at midday, and there's an overall high temperature bias of the clima over the hydra. It's not exactly sure which one is more accurate as to whether the hydra is perhaps suppressing diurnal cycle while the clima is accentuating it, but clearly there's going to be a discontinuity in the temperature records, which is unfortunate in this transition. As I mentioned earlier, we will be taking our standardized soil moisture product that's been around for a while and making it operational, where it's going to be updated in real time on an hourly basis. And we'll also be updating the soil moisture climatology product that goes along with that. That's on an annual update cycle, but is necessary to update both the climatology and the standardized anomalies when we update the climatology. So the entire set of standardized anomalies will also be updated. The newer product that hasn't seen too much visibility yet is Drought Indices product that's based on the standardized products, which will be a 7-day average of hourly soil volumetric water content, hourly standardized soil moisture anomalies, and also the percent counts of hours that are less than the 30th soil moisture percentile and greater than the 70th soil moisture percentile. This was recently published in June, and we're looking forward to having the community of U.S. Drought Monitor authors use this to get an idea of direct drought indices based on the soil moisture data itself. You'll be able to find these as well as the other described data sets at our quality control data set link at the bottom of the page. The other research and development that has been going on as an offshoot of the Drought Indices project, we've developed a climatology of U.S. Drought Monitor defined drought states for the NCLIME grid data set, i.e. 5-kilometer grid that covers the United States. And so you get a really a very acute spatial pattern of things like the number of drought events occurring during the first 20 years of the USDM, or the length of time spent in drought on the map on the right. We're also continuing our research in soil moisture standardization and applying it to the ESA, European Space Agency, CCI soil moisture data set. Chose that one because it's a bit longer than SMAP or other available single satellite data sets. It's a blend of multiple satellites, and the short-term interval period has lots of active satellites also, and the longer-term period is mainly dominated by the passive microwave data sets. So we're standardizing both in the same manner that we have also standardized our in situ data, with the idea being that we feel that using the same methodology for standardization in both will make them more compatible for blending purposes. That project is still ongoing. The other bigger project that just is beginning to start but will be a dominant feature in next year will be our examination of compound hazards of of drought and heat waves, and using USCRN soil moisture to understand the interactions between the two and their health impact. You can see here some of the preliminary results gathered by our summer interns during their work on the compound hazards project, and you can see that heat waves tend to be more intense, have a maximum heat index that's higher in the more humid areas of the country, in the Midwest and South and Southeast. You can also see in the lower right that when you compare heat waves during droughts to those occurring not during droughts, that the air temperature tends to be warmer. However, the heat index during the same comparison can vary depending on the local circumstances. And for instance, in the Southeast, it tends to be a lower heat index during a drought than a non-drought period, while in the Midwest, it tends to be higher. So we have upcoming in the next fiscal year, continued improvement of our quality control in real time. The HydroProbe retrospective improvement project, which we're going to try to use different equations than the Lohm equation to translate real dielectric to volumetric based on a new set of soil characteristics we've gotten in a recent study. And then finally, working more on this compound hazards project. So thank you for your time, and again, our web link and our quality control data set link. Thank you very much.